This is 11.5, and so what we've done so far is try to understand what a square root is and learn some terminology. Then we dealt with the Pythagorean theorem and found out that we can use square roots to figure out whether a triangle is a right triangle or not, and to figure out one of the three sides of a triangle if we know the other two sides. Well, now what we want to do is learn how to multiply radicals. It's pretty easy. Multiplying radicals is pretty easy. One thing you have to understand up front, you can only multiply a square root times a square root. A cube root times a cube root. That's all we're going to deal with in this course. When you get to Algebra 1, you can do a fourth root, a fifth root, a root of bitterness, all kinds of roots, root beer, all kinds of stuff. But in here, we're only doing square roots, sometimes cube roots. So in order to multiply radicals, it's got to be a square root times a square root. Now, technically, you really can do it if it's not a square root and a square root. But then you got to start applying some more complicated math concepts, and that's a higher level course than we're in right now. So for our purposes right now, we're at the point where we're just saying, hey, in order to multiply, it's got to be square root times square root, or cube root times cube root. That's the situation. That's what it's got to be. And if not, we can't multiply them. Now, it's pretty easy. And if you use your color here, all we're doing is multiplying the radicands. So I'm going to take my blue and draw the radical sign. And then I'm going to take my red, and as part of the radicand, it'll be an A. And take my green times B. You simply multiply the radicands. So how do you multiply radicals? You multiply the radicands. Pretty easy, pretty simplistic. So if we were doing a problem like A here, just to be clear and use the rule step, the radicand would be a 3 times 7, right? We're not going to leave it like that. We will then end up with a final answer. Pretty simplistic. And this is going to be the square root of 21. So the square root of 3 times the square root of 7 is the square root of 21. You multiply the radicands. That's pretty easy. So therefore, if you did something like B, again, if I were to show the rule step, and I will on this one, when you guys get to your homework, I'm okay with you skipping the rule step. It's pretty simplistic. Your mind should be thinking, hey, I got to multiply the radicands, right? The stuff under the radical sign. So this is just the square root of 55. So you can do a shortcut if you want on C. What would you get multiplying C? Of course, I know you can't figure out C because I didn't teach you how to do 3 things, and that would be impossible, and math is so hard anyhow, so there's no way you'd know what to do. But I guess if you tried something, you'd probably say it's the square root of 30. Right? Square root of 30, because math makes sense, and if there's 3 of them, multiply all 3 radicands, and if there's 4 of them, multiply all 4 radicands, etc., 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 etc. Well, now we got to talk about simplifying. Simplifying radicals. All right. Technically, to simplify radicals, split them up into parts that, and then look at the red. I'm going to underline it. You can take the root of. Split them up into parts that you can take the root of. Here's what we're doing. We're kind of doing multiplication in reverse. We're unmultiplying, which we commonly call what? What do you call unmultiplying? You could say dividing, but there's a better way of thinking of it. What's unmultiplying? Edward? Not reducing. For example, don't write this. Let me give you an example. If I had the number 6, I could write it as 2 times 3. I unmultiplied it. What did I do to say 2 times 3? Edward?
2 times
I factored it. Really, unmultiplying is factoring. Go backwards. And it's a means to an end. You only factor when it'll give you some benefit. It'll allow you to do something else. Well, here, with some radicands, if we unmultiply it, we can simplify it. So, if I want this 40 to be simplified, I can change it into the square root of 4 times the square root. Somebody raise your hand. What would be the other radicand? Amber? The square root of 10, right? Because isn't a 4 times a 10 a 40? And why did we pick the 4? Because the square root of 4 is 2. So I'm going to take my red. Whoop, that's supposed to be red. I'm going to take my red, and underneath the square root of 4, I'm going to write 2, because isn't the square root of 4 a 2? And then I still have times the square root of 10. But I have just simplified that radical. Now that's as far as we can go without rounding off. Right? In the homework we just went over, didn't you guys round off some of your square roots to 1 decimal place? Were those exact answers? No, they were round offs. And we could get a round off for the square root of 40. It's going to be 6 point something. You could punch it in your calculator. But I don't want a round off. I want an exact answer. So, by the way, go ahead and punch in the square root of 40. And somebody tell me what that number is. And nice and loud so I can hear it. Don't you write it. I'm going to write it. Hannah, what's the number?
6.3.
But what's after the 3? Don't round off. Just give me like maybe 5 digits after the decimal point. 6.32455. That's enough, and we'll leave it at that. Okay. So that's the square root of 40. Agreed? All right. Now I want you to punch in the square root of 10 and multiply the answer times 2. Do the square root of 10 and multiply it times 2. All right. And then somebody raise your hand and tell me, Brendan, what do you got?
4.472.
All right. You punched something wrong. Christina?
6.3.
32455, right? Yeah, always be careful punching, right? It's easy to push a button, or, you know, sometimes your keyboard, the number doesn't come out even though you press it, so be careful. Sometimes that can happen. So square root of 10, but then you have to finish that and then multiply by 2. Brendan, I think yours gave you the square root of 20. So I think you hit square root button, and then I think you did 10 times 2, and it treated it like the square root of 20. If you do square root of 10 and hit your enter button and total it, and then multiply that answer times 2, then you'll get 6.32455. Or you can do 2 times, then your square root button and 10, and it'll give you that. Same answer, isn't it? See, here's the point. The point of it all is this. 2 times the square root of 10 is an exact answer. It's exactly the square root of 40, but it's a little simplified. And sometimes we'll be able to use that in a better way than we could the square root of 40. Questions on this? This is an important concept. Kristen?
You've done square root of 4 times 5.
You could, and times 2. So Kristen's saying something like this. Don't write this. What if I made this square root of 5 and made this the square root of 2? You could, but again, these are of no value, and I would multiply them back out to a 10. Because I can't do anything with a 5, and I can't do anything with a 2. But you could. You're always looking to try to make things that you can take the square root of. Now, by the way, before I forget, if you don't have your calculator with you today, will you please stand? Anybody in that situation? No calculator today. Just Edward. Okay, Edward, come borrow mine. Tomorrow I want you to show me your calculator without me ever asking, okay? All right. So, with that in mind, we want to split these up into things we can take the square root of. And look, we should all know some definite things to take the square root of. We know the square root of 4 is,
2.
the square root of 9 is, the square root of 16 is, the square root of 25 is, the square root of 36 is, the square root of 49 is, the square root of 84 is 64. Square root of 64 is a square root of 81 is, square root of 100 is, square root of 121 is, square root of 144 is, the square root of 169 is, the square root of 196, I think. Most people don't know that one. Square root of 225 is 15, etc. All right, so that's what you're after. So with that in mind, how would you split up the square root of 45? And look, you can do it this way as well. You can factor the 45. What are you looking for? 4s, 9s, 16s, etc. So it doesn't take a rocket scientist to say, oh, 9 times 5 is 45, right? So let's make it the square root of 9 times the square root of 5. Does that make sense? Because we can take the square root of 9. So we all know the square root of 9 is 3, and we end up with 3 times the square root of 5. Okay? That is in simplified form. All right, so we got to deal with some more simplifying. So let's write a little bit here. All right, number 3. Remember, the index of a square root is 2. Meaning, what number times itself twice equals the radicand? Oh, I want that to be red. Keep hitting my green when I want red. Radicand. Or is a factor of the radicand. I'll explain that in a minute. Emily, question?
Letter B.
Yes. You could. And if you did, so Emily says, what if she wrote square root of 5 times the square root of 9? This square root of 9 would be the 3. The square root of 5 would be there. But it's always proper etiquette to put the number in front of the radical. So the square root of 5 times 3 is the same as 3 times the square root of 5. By what property, Emily? What allows us to? It does start with a C. Help her out, class. Commutative, right? So whether you have the 3 times the square root of 5 or the 5 times the square root of 3, of course they are equal. They're being multiplied. The commutative property of multiplication allows us to do that. But proper etiquette is number goes in front of the radical. Okay? Good question. All right, so let's take a look at these. Here's really, and I need to go higher, so I'm going to get rid of my screen. Here's really the concept. I need you guys to really focus in. Let's take our red and let's factor our 56. Now, it doesn't matter how you start, but stay with me. Don't go ahead now, because I need to teach you guys something here important. This is setting up what we're doing next here, and simplifying radicals is important. Let's go for a 2. Now, you can factor 56 a lot of different ways, but I want to go for a 2. So 2 times what is 56? 28. Okay. Now, you may have chosen a different route. That's okay. But I just want to show you my thinking. Now I'm going to deal with the 28. 28 is a 2 times 14, correct? Why did I go this route? Here's why. What's my index? What's the value of my index? 2. How many factors do I need to be able to take a square root? The point is I need 2. Do I have 2 2's?
No.
I do. I have 2 2's. What is the square root of 2 times 2?
2.
What is the square root of 2 times 2? Do you believe that? So watch. Here would be the long way at this point. At this point I can take this 2 times 2 and make it a square root of 4, and then I still have a square root of 14. Now you might ask, Mr. Scarfi, why didn't you keep going with the 14? because I'm only going to have 1 2 and 1 7. Can I take the square root if I have only one of something? No. Here's the point. To take the square root of something, if you have two of the same thing, the square root is one of them. Isn't the square root of 2 a square root of 4? Isn't it a 2? How did we get 3 when we took the square root of 9? Because guess what? A 9 is a 3 times 3. The square root of a 3 times 3 is a 3. What's the square root of a 7 times 7? 7. What's the square root of an 11 times 11? What's the square root of an x times x? X. What's the square root of a z times z? Z. The square root of any two things that are the same is it. So, long way would be to split it up, take the square root of 4 and get 2. It's a long way. The short way, take your green, is right off of this. When I circle those two 2's, I take the square root and get a 2. And what's left is the square root of 14. Either way you look at it, you end up with 2 times the square root of 14. If you want to be more formal, you can do it this way. If you want to be a little quicker and do it in one step, you can do it this way. Here's the point, though. If I'm doing a square root, how many of the same factor do I need? 2. If I were doing a cube root, how many of the same factor would I need? 3. Cube roots are different, right? What number times itself 3 times? All right, so let's keep going in this thought. So here, when I get to the next one, and I'm going to do 98, I'm going to start factoring it. And how many of the same factor am I looking for? 2. So again, you can do it any way you want. I like to do 2's and 3's to get started here. Sometimes a 10. Remember how we factored with a factor tree? Same concept. So 2 times 49 is a 98. You already see where this one is going? Now some students can stop and say, because this is so familiar, what's the square root of 49? Yeah, and because you know why? Because a 49 is a 7 times 7, right? So whether you think it of a square root of 49 or square root of 7 times 7, again, shortcut way, what's the square root of a 7 times 7? It's a 7. And what's left? The square root of 2. Where is that 2? Under the radical sign. Why is the 7 out? Because listen, why is the 7 out? Because we took the root of it. We did the operation. We operated on it. We got it out. You want to think of it as jail, and the 7 got busted out. Maybe it got paroled. All right. Maybe its time is up and its sentence is over. All right. But when you take the root of it, you perform the operation. Therefore, it comes out. Performing the operation, you come out of that radical sign. Because remember, a root is an operation. It tells you what to do to the numbers. Just like a 2 times a 3. That raised dot tells you to multiply the numbers and you say 6. Do you have a raised dot anymore? No. Well, in these kind of radicals, do we get everything out? We don't. We're only able to get some part out. And the part we get out comes out and is a multiplier, and whatever's left in stays in. That's the shortcut way. If you did it the other way, you would have done the square root of 49 times the square root of 2. Again, you would have said the square root of 49 is 7, and you still have a square root of 2, and you end up in the same place. One way is doing it right off of the factoring. The other way is being more, a little bit more formal. All right, now that's going to lead us to C. And again, guys, you need to raise your hand and ask questions, and I'll try to approach it a different way to help you to understand. Watch what happens in C. I'm going to take my red, I'm going to factor my 6. It's a 2 times 3. You agree, right? Can we take the root of anything there? No. Now I do my 10. It's a 2 times 5. Can I take the root of anything there?
No.
No. But let's multiply them. But let's leave them in factored form. Take your red and make your 6 your 2 times 3, because isn't that 6? And take your green and leave your 10 as a 2 times 5. And you might say, Mr. Scarfi, I just want to multiply them and make a 60. Au contraire, you are wasting your time. You're wasting your time. You guys remember arbum? Reduce before you multiply? Because if you multiply them out, then you got to unmultiply to reduce, and you're wasting your time. It's kind of the concept here. Can I multiply 6 times 10 and get 60? Yes. Is this the square root of 60? Yes. But if I want to simplify it, I'll have to factor the 60. What do you want me to do? Go right back to 6 times 10? I just went right back to where I was. Why would I bother to say 60, then go right back to 6 times 10 to begin to figure out if I can take the root of anything? So, can I take the root of anything? Do I have 2 of anything?
Yes.
I'm going to use my blue. Don't I have 2 2s? Right? Isn't that what I need? 2 of something? So what's the square root of 2 times 2? So I'm going to cross them off and I'm going to put a 2. Can I do anything with the 3 and the 5? So therefore it's going to be 2 times the square root of?
15.
Does that make sense?
Yes.
2 times the square root of 15. So by themselves I can do anything with the numbers. But with their factors I can. I'm going to add one more, so go back a page. So why don't you guys try this one? Let's do the square root of 15 times the square root of, let's go with 30. Square root of 15 times the square root of 30. See what you can do with that. Simplify that. I'm going to pause and let you guys think through that. All right. There are a couple ways of factoring. Agreed? Want me to show you the easiest way right off the bat?
Yes.
Okay, because I'm looking at the Radicands. And how many of something do I need?
2.
I need 2 of them. Don't write this, because probably none of you did it this way. But if I wanted to, I could make the 30 a 2 times a 15, right? Did anybody go that route? Oh, a few of you. Okay. So again, I'll show you another way in a moment. So now we got 15 times 2 times 15. And now, what's the square root of 2 15s? I don't even need to go any further.
Oh.
The square root of 15 times 15 is? Did anybody go that route? See, I didn't need to go any farther. How many got 15 times the square root of 2? All right. So again, I doubt you did it that way. I just know the numbers, and so I saw that that's a possibility. Here's probably the way you did it. So now if you factor a 15 into a 3 times 5, 30, I don't know, 3 times 10, and then 2 times 5. Now when you put it all under 1, you have a 3 and a 5 from the front one, and you have a 3 and a 2 and a 5 from the back one. How many went this route? Factored it completely. Okay, and that's more normal. So how about this 3 times that 3? Square root of that is a 3, comes out. How about this 5 and this 5? Square root of 5 times 5 is a 5, and that 5 comes out. What are we left in with? Square root of 2. Did you finish by multiplying the 3 times 5 and still ended up with 15 times the square root of 2? How many got that? 15 times the square root of 2. Questions. You need to ask me questions if that didn't help you to understand. Questions. Questions. Is it just a mistake why you missed it, or you're not, what's the reason why you missed it? It's a mistake, okay. Is it a concept that you're not understanding? Kristen.
Did you have 2 15s?
Why do I have 2 15s?
For you,
So remember, I did it 2 different ways. That was the first way. Remember, with a square root, how many things am I looking for? 2 of them. I recognize right off the bat that there's 2 15s. And I don't have to go further. I can just take the square root of a 15 times 15. Or if I don't recognize that and I factor completely, see, I still get a 15 out, but I got it out in pieces. I got a 3 out and I got a 5 out in pieces. Any other questions on this? Amber?
I got the answer right, but for the first way you factored it, I factored both 15s and 30s, and so for 30 I got 2 and 15, and then I factored 15, got 3 times 5, and then for the 15 I got 3 times 5, so I ended up getting the square root of
Yeah, and the way you go after your factoring, Amber, is up to a personal preference kind of thing. So again, it's an individual thing. As long as you factor correctly, you'll end up in the right place. But that's why I said there's a couple ways to skin this cat. And even the way you factoring is fine as long as you factor correctly. So I like to take 10s out right away, usually, and normally I do the 3 and the 10, but you can go a different route. Okay, so that's multiplication. What about division? Notice here we have a fraction for a radicand, right? What's under the radical sign? A fraction. These really are not hard. What you do is you split it up. The numerator of the fraction is the square root of the numerator. And the denominator of the fraction is the square root of the denominator of the radicand. And that should have been a blue. Man, I'm hitting all my wrong colors. What in the world? So you end up with the square root of A over the square root of B. Or the square root of the top divided by the square root of the bottom. What if it would have been a cube root? What would you expect? What? Don't write it. But what if there would have been a 3 index? What would you expect then? What would the rule be? Amber?
the cube root of A divided by the cube root of B.
Exactly. Does that make sense? Math is orderly. So, we did square roots, but if it would have been a cube root, it would have been that. Okay, so let's take a look at a couple examples here. So, don't let a square root of 81 divided by 4 scare you. It's simply the square root of the top, 81, divided by the square root of the bottom, 4. Can we simplify the top and the bottom? Sometimes you can only do the top. Sometimes you can only do the bottom. It just depends. We all know the square root of 81 is, and we all know the square root of 4 is 2. And what's the answer to that? 9/2, right? Commonly known as 4.5, but we leave things fractions, right? 9/2. Hey, that's doable. Got rid of the radicals. Cool. So here's a second scenario. Go ahead and do that one. You do it. I'll do it as you're doing it. I'm still color-coded. It should be easy. And hopefully you got 13/10. Square root of 169 is 13. Square root of 100 is 10. All right. Now this is where things get a little tricky because sometimes there's no clear way to tell you, class, always do this. Now it gets into a little bit of thinking. That's a little bit harder to teach and a little bit harder to understand as a student because you don't do the exact same thing every time. The problem dictates what you do. That can be a little difficult. But I'm going to introduce you to a concept. Sometimes you can reduce if you put them back together first. do anything with the square root of 10? The answer is no. It's an exact answer. It's 3 point something, but we don't want to round off. Can we do anything with the square root of 2? No, it's 1 point something. And again, we don't want to round off. We want exact values. So seemingly there's nothing we can do with this. But watch. Let's do the division rule backwards. Let's do it backwards. Let's put them back together as a fraction. And hopefully you agree that it's the square root of 10 divided by 2. Right? Do you see how I took this rule and went backwards? I went from this to that, right? I went backwards. Instead of splitting it up, I put it back together. Now again, why would you do this? Only if it's to your advantage. Is it to our advantage to have a 10 divided by 2? Don't we all know what 10 divided by 2 is? 10 divided by 2 is 5. So now what do I end up with? Square root of 5. Isn't that a better answer than the square root of 10 over the square root of 2? Say, Mr. Scarfi, I would have never have thought to do that. Yeah, I know. That's why I showed it to you, right? So there was an advantage to putting it back together as 1. Say, how would I know to do that? You just got to look and see if the parts would reduce if they were together as 1. If they would, then put them back together as 1, reduce it, and then go from there. All right, so I got one more problem here. Now, it's in this section, so obviously it goes together as 1. See what you can do. Go ahead and see what you can do with this and finish it off. See if you can simplify it. And then you may have to split it back up after you're done. So you may need to put it together as 1, reduce it, and then split it back up. See where it takes you. See if you can finish this one. So hopefully you put it back together as 1. Said, oh, I can reduce. 15 is a 3 times 5. 20 is a 4 times 5, and my 5s divide out. Then you split it back up. Would you agree that's where we're at right now? Finish it. Can you do anything to the top?
No.
It just stays. But can you take the square root of 4? Sure, and it's a 2. And we end up with the square root of 3 over 2. It's an exact answer. Now, by the way, if you're taking a quiz or test, you can check your answer. You can, on your calculator, do the square root of 15 divided by the square root of 20. And look at the decimal answer. It'll give you a round off. And then take your answer, do the square root of 3 divided by 2, and see if they're exactly the same number. If they are, you did it right. If they're not, you made a mistake. All right, got it? All right, pause. I need you all to look at me for a minute. I need to do a quick recap here. So look at me. Stop. Stop packing up and look at me. So a couple things. Multiplying radicals. We multiply the radicands. However, at times you can simplify, and then dividing, that's the bell. I'll leave it at that. Video will be on HCS Math Class if you want to go back and look. Quiz tomorrow.